So this question begins with the observation that 49 is 4 times 9 plus 4 plus 9. You can see a pattern there. And you're asked to understand if there are any other two-digit numbers which have the same pattern. So we have to be careful to clarify what we mean by the pattern. Well, I'm going to write this as A, B. I'm going to look for two-digit numbers. So this is the first digit, corresponding to 4. This is the units digit, corresponding to 9. And by biting that line over the top, I mean that this is a decimal number. It's not A multiplied by B, which it might be if I didn't put that line there. On the other side of the equation, I will have A times B, which you can write like that, or you might put a times sign in between, plus A plus B. And there will be some restrictions here. So B is a digit. There are lots of choices for B. And A is also a digit, but it can't be 0. So there are 10 choices for B, but only 9 choices for A. Now, we have to do some algebra and investigate when this can be true. Well, how do we change this AB with a line over it into something we can understand? Well, 49 is really 4 times 10 plus 9. AB with a line over it is really 10 times A plus B. And on the other side of the equation, we'll keep it the same. So, subject to these restrictions on A and B, we want to know what are the solutions of this equation. Well, helpfully, there's a plus B here and a plus B there. So I can take B away from both sides, and that'll disappear. Now, we derived this equation here from the equation above, but we could do it the other way around. From this equation, we could add B to both sides to obtain the equation above. So the two equations are logically equivalent. To say one is to say the other. So we can write the right-hand side as A times B plus 1. These two equations are logically equivalent. Both sides have a factor of A, and A is known not to be 0. So we can divide through by A. So this last equation is equivalent to the one before. But this, of course, says B equals 9. So B is 9. There's no restriction on A at all. Doesn't matter what it is. So A can be 1 or 2 or 3 up to 9. So this tells us that the numbers we're looking for are 1 followed by 9, 2 followed by 9, and so on up to 9 followed by 9. There are 9 such numbers, so we're in business. The answer is 9. And if you're nervous, you can check that each one of these numbers does satisfy the original condition. If you want to have fun, you can make up your own questions like this. I mean, there's nothing very interesting about 49, is there? So let's start with 37. You make the brilliant observation that 37 is 3 times 7 plus 3 squared plus 7. I wonder if there are any other two-digit numbers that are like that. Investigate and make up your own questions.
you.